everybody to Globebusters.
We accept the reality of the world with which we're presented. It's as simple as that.
All right, hello and welcome to Globebusters, Season 13, Episode 7. Today, Shane and I are going to be going over Big G, Little G, and the substantiation and proof of all of these things and how they are applied to cosmology and physics. And before we get to that, there's going to be an update to the celestial theodolite that Shane's going to lead us off with. But I'm going to give a quick, actually, I'll lead us off with it, and then Shane will show you how to replicate it yourself. So I wanted to cover an important point that, actually, let me introduce everyone. Sorry, before we get into everything, I skipped ahead.
We're ready. We're rolling and ready today, guys.
Yeah, sorry about that. We're joined here today by Good Times for All, Zachary Zambala. What's up, Zach? How are you, sir?
On, fellas.
How have you been
too
this
bad,
week?
Not too bad. Pretty good. Weather was okay. I know, man, did you see the Midwest got hit? Like real bad with floods and all kinds of stuff. I know Virginia too. So yeah, a lot of prayers and all that kind of good stuff. That's the one thing. I mean, Mother Nature will make you realize how small and insignificant we really are. Ted and I were watching, they came over this weekend, Ted and Karen, and we were watching, have you ever heard of Ryan Hall, y'all?
No, never met him.
He covers national weather, like tornado forecast. He's better than any like major weather station out there. He just has great coverage. They have a lot of boots on the ground and stuff. But we were sitting there talking about how much water is actually up in these clouds, how many miles tall these clouds are, and how many miles they cover. Like we are so insignificantly small compared to Mother Nature, and it's just a reminder every once in a while when Mother Nature lashes out and just teaches us how small we are. It's yeah, that's the one thing that I fear more than anything is weather. Like that's the one thing that get me, the hair standing up on my neck and all that kind of stuff. Is
Yeah.
it's
Yeah, floods are
oof.
intense.
Yeah, and there was like houses, halfway underwater
Worst.
from just like 2 days of rain. Yeah, just crazy. So yeah, it's one of those, just a reminder how small and insignificant we really are, and it's nice that they're finally backing off on some of this climate change stuff. Like we could actually affect the climate. I bet if we actually tried to pollute as much as we possibly could
We couldn't do
as a
it.
whole human race,
Couldn't
we
do it.
wouldn't scratch the
Nah.
surface of this place.
Nah,
At
probably
all.
Dude,
not. We'd all be dead before we did anything harmful to the earth.
Yeah.
I'd be so much more willing to believe them if they didn't write, publicize, and publish a book that said that they would look for a boogeyman to blame it on climate change, to turn us into the enemy, and then publish that. I'd probably believe that we were causing it if they didn't do that, right?
The chances that you would believe it would increase if you didn't have the foreknowledge of them telling you that they were going to do it beforehand.
Yes, exactly that. Yeah.
Yeah, that usually puts a damper on it. But much appreciated to the lads and ladettes who put that stuff out for us to to know about. But anyway, Shane, how was your week, sir? You been good?
Oh yeah, it's been fantastic, man.
Nice. Same here, brother. Same here. Well,
Dude, I know what I did was I watched Globebusters Tech, and you guys did an awesome thing on the tides that I was super into and watching. And
Nice.
in retrospect, it was awesome and really cool.
Nice. Yeah, we're going to cover a little bit of that today, I think, towards the end.
Yeah, that was a fun show. I learned quite a bit that show. Just, I mean, it's all
Gotta get the
cymatic.
metrodromic points, man.
Everything is frequency and vibration. That's just how it works. It would make sense that it has to do with the tides as well.
They say everything is gravity, right? But it's never substantiated. So that's just the world we're in. Everything is gravity, but really it's semantics and frequency and patterns.
All right, so let's start with the celestial theodolite update, and then we will get into Newtonian dynamics and Kepler's kinematics. Screen, everything. Good. For Kepler. Other thing. Here we go. All right. So a couple of days, or it's been about a week since we put out the last Glowbusters episode presenting the celestial theodolite and the implications of it. And we took it around the block arguing it to see what kind of refutations we would get. And so far, we got that, well, Mike must have measured the incorrect angle. And here's where we're going to get into why that doesn't matter about the accuracy of his device or anything like that, because people have made arguments that, well, this device isn't technically a theodolite, blah, blah, blah. It's just it's a transit device. Well, either way you slice it, it's still within 5 arc minutes of accuracy. So it's within the air tolerances to measure the globe to begin with, so they say, right? So it's kind of like a moot point for them to take it there, because what ultimately happens is what this whole thing is based off of, right? What this whole thing is going to be based off of is the precise time that this star is occluded by this mountain peak here and your position away from it. That's all you need to know to get the angle in your elevation. So once you have your calculation for your prediction for the raw flat Earth angle, and you confirm what time a star would be occluded there using stellarium without using turning refraction off, and you go out and observe from this location at this elevation, if you observe that star being occluded, you've eliminated all the refraction between you and the mountain. So how they say, well, the mountain's lifted up, because of refraction, even though they're supposed to be about, what was it, like 600 something feet missing due to Earth curvature at 50.7 kilometers. So they have to lift up the mountain. They have to make it equivalent to us with corrections, with refraction. But the refracted object it can't refract, it can't block a star. That's not a real thing. So only the physical, actual mountain peak would block that star. So the physical, actual angle is correct there to that mountain peak. You know that it's physically there at that location to occlude that star at that specific time. That is the celestial theodolite. The mountain peak is the crosshair of your theodolite. The star timing intersecting with that confirms the accuracy of your angle with respect to the elevation that you did your prediction with, which would just be flat Earth prediction. Like that's your baseline right there. That's just plain trigonometry. So the only way that they could match us is by saying, oh, well, the star's over here behind us. It's up here, but it's really down here. The mountain's below us, but it's also above us, and the starlight's bending around. None of that matters. The only thing that matters is that starlight is getting occluded by that mountain peak at that time. That is the key takeaway for this. And Shane is going to show us how to replicate this per the instructions given here in this. Do you want to screen share for this? I think there was one more thing. Yeah, it's Dr. Mike Heffron. Dr. Michael Heffron. Yep.
And I love the idea of taking the elevation angle from the top of the mountain at the same time, and it should be even less because it's curved, or even more because it's curved down a little bit, right?
Completely irrelevant where it's at after that. But
yeah,
when
like the measurements shouldn't be the same from the ground and the top of the mountain. The measurement should be different if you're on a curved surface.
They would make two different predictions. Yes.
Just genius. So well thought.
Yeah, it's insane. There was one more thing I wanted to show from here, but I can't remember. It was the the corrections. It was GG Bennett. So yeah, this was called into question. It was celestial refraction versus terrestrial refraction, et cetera, et cetera. Well, when you apply the corrections, you get the exact same result for celestial refraction. So the globe only exists in this correction to make up the difference between the two. So when they have to correct their measurement to our prediction, it's over. Our raw uncorrected measurement matches the elevation angle and the timing that star was occluded, making that mountain or whatever reference you're using physically there and at that angle. So all right, so that's the update for that, and then Shane's going to show us how to replicate it. Stop screen sharing here.
I was gonna say, how do I share? Why is it blocked out?
Oh, it was because I was screen sharing at the time. You should be good now.
Still says blocked out. Oh, wait, do this way. All right.
Oh,
Stellarium.
yeah. There you go.
Gotcha. Ooh, sharing sound.
Is that AI art right there?
Who?
The image we're looking at
It's Stellarium.
on YouTube. Now I'm seeing something totally different on YouTube. It's like a castle, like a
Oh,
rock arch. There you go.
is YouTube updated properly?
It looks good to me now. It looks like Stellarium.
Yeah, it looks like it's Tellurium now.
Oh, that
What
was
you
my
been doing,
wallpaper.
Alan?
No, that was my wallpaper. You're good. You're good. You're fine.
All right. So we quickly open this up and we're following his lat long, his position, and we're looking for an azimuth and an elevation, right? So it starts with this apparent. Actually, let's just figure how to do it. Let's go to like location. All right, you'd enter your GPS lat long here. Notice I already did. I called it over here. This is my location. It's 38, 50, and 25, I think. And then his longitude was west 105 to 40. That's close. I don't know why it did that. 40. Close enough. Right. So then we use that location we go there. And then we're looking for the real reading. So this is the atmosphere button. We'll be turning this off and on to get our measurement. We'll leave it off for now. When we're looking for a star, I think it's called, let's see, he used 39 Aquarii. I don't know what that is, but if you type that in here, it'll find it for you right here in the search window. I already searched for it. That's what it ends up being. So 39 Aquarii over here. If you look where it is without the ground, it's right over here. Of course, it's being occluded by a mountain. We're not seeing the mountain in Stellarium. That's not what we're confirming. We're confirming where is this star. So we look over here. We have it selected, and it's giving us an alt, right? An alt as. So here's our azimuth. Again, that's 360 degrees of direction from true north. So all the way around at 0 to find this direction bearing. And then 232, 55. So that's almost exactly what he has. We had 231. I couldn't get it to replicate that within an arc second, so that's fine. If we turn off the ground, you'll notice this. If we turn off the atmosphere, rather, you notice this all switches to apparent. And I think this is what he says the globe prediction would be, right? So literally turning off and on globe prediction with this button. Globe, flat Earth. Globe, flat Earth. Globe, flat Earth. So there you go. So that's how you'd replicate it. And I went to his position. We looked at the star. Oh, I also set the time for exactly this time. Very important. January 31st at 6, I think 27, 25. I think, yeah, 6, 27, 25. So that's very important to find out where the star is going to be occluded. And of course, we were looking for the direction and the elevation. And that's how anyone can go into Stellarium and replicate the results. And again, you can always turn atmosphere on and off. It's a very easy button. You can do it on the web version a little bit easier, but then notice how it changes this reading up here. There you go. There's that update.
Awesome. So there's how you can replicate it for yourself, and then you could use anything. And if that timing matches, then you're good to go. And all you need to do is have equipment to take a picture of the, before and after of it being occulted. So you have the timing and, then you have your measurement there. So none of this actually requires you to have an expensive theodolite or tilt your theodolite plug bob or anything like that, or make any assumptions. You're just literally calculation. This is what it would be on a flat earth if it existed there. And then, oh, look, it blocks a star at this specific time with the respective flat earth corresponding elevation angle. I wonder what that means, boys. Let
Very
us think.
keen on Dr. Mike. He pointed it out. He's like, wait, if I had a refraction correction, it takes my flat earth prediction and turns it right into the globe prediction. What are the odds of that? I was like, that's a very good point, Dr. Mike.
All right. Awesome. Thank you for the update, Shane. So now we will get into the main subject. Zach, have you ever heard the claim, well, how come Newton's laws of gravitation can predict the orbital periodicity of Jupiter's moons?
Mm-hmm. I've heard that so many times.
If
Gravity can prove everything, every motion in the solar system. I don't know why you guys don't get it. It's like
we apply big
G
G
body problem.
We apply big G to the planets individually, then superimpose them together as a unified dynamic system. But we'll just, let's not talk about that. Let's just talk about singular instances of GMM over R squared working.
Not all 54 moons or however many there are. We don't do that. We take one moon with that planet and we'll tell you exactly what it's going to do.
Yeah.
We don't throw anything else in there. You can't put another moon in there.
Can't do it.
The greatest supercomputers on Earth. It just goes all haywire and wacky and things start getting flown out and it's nonsensical.
Now keep in mind, they've come up with solutions to impose what the predictions would be, but they don't actually have a way to solve it. It's not like an actual solution in like a meaningful way that the system is explained dynamically. So there is no actual solution to it, but they're super involved in the role play and the math does work out. So we're going to dive into specifically how that interaction works out and what these constants are and what you could do with constants and ratios. Because it turns out you can define all of physics based off of some agreed upon ratios and go from there. So it'll be interesting to go through that. So let me start the screen share here, and we'll start with the astronomical implications of applying big G to the sky, which is derived from little g. But Shane will be covering that part of it here. So screen share.
Some of my favorite topic, dude, because this really strengthens our position, and most Globers who argue it don't know this level of detail on it. So it's fun to educate.
Yeah, once you guys really started digging into it, I mean, the arguments that were had before, it was not so much getting into the nitty gritty of the equations and all that kind of stuff. Once you two came along and, in Austin, I mean, it's been a totally different, like they have nothing to say anymore. Like there is no rebuttal.
They still say flirts don't know how to math though.
They still just say the same things, but yeah, we have a really strong crew, man, and shout out to all the lads and ladettes who are behind the scenes at Ether Cause helping us out with all of this stuff.
Shout out to Witsit over there on Modern Day Debate.
Dude, he's out there
crushing
out there in the streets.
That was kind of an easy one to debate against, though. Just say. But props to him for going out there and doing it. I mean,
yep. Yeah. So I remember being asked that very question about Jupiter's moon's periodicity in using big G in that relationship a couple of years ago, and I was like, that's a good question. I don't know how that works, but there must be something that I don't understand that somehow makes it all magically work, right? And which is a weird position to take, right? Because that's like appeal to infinite possibility or whatever. But as it turns out, a couple years later, we had Dr. Bennett on Witsit's channel doing his presentation on science propaganda. And one of the things he covered was the relationship between Kepler's laws and Newton's laws, which is this GMM over R squared relationship, where they're asserting that without knowing the mass of these planets and the gravitational potential relationship between them, they can predict the motion of these bodies with these equations. That's what these equations are supposed to represent for them. So they apply like physical meaningfulness to them in that relationship with the interactions with gravity based on these variables here. This is the big G is supposed to represent the gravitational potential. The big M is a mass of the body that you're using. So if you were using the Earth, you would use the mass of the Earth, and then you could backwards derive what the mass of the Sun would be using the mass of the Earth with this exact same equation, and then doing it outward. Then doing it for other planets or stars or whatever, you would just use M for the mass of the sun as your constant there, and then the other M would cancel out. Doesn't matter. You don't need to know it, but you could backwards derive it always from this relationship, and it would always share proportionality because it's over a constant here. But we're going to get into what all this means specifically as we go forward. So Kepler's third law is that the square of the periodicity is proportional to the cube of the semi-major axis of the orbit. So in other words, they're telling you that based on how long it takes something to complete a circuit in the sky, the square of that time is proportional to the length of the semi-major axis of its orbit, meaning it's going to give you the radius of the ellipse, essentially, or the radius of a circle of the orbit if it's a circle. For what we're doing here, it'll be for a circle, so we're going to do pi, but that's the relationship. So in other words, it'll give you the astronomical unit, essentially, right? So it'll tell you how far the Earth is away from the sun, and you could do this all based off of kinematics, because this is all just based off of empirical observation. We're not making any initial assumptions before we do the algebraic swap in, but we're going to go over Kepler's laws first and talk about kinematics. But before we do that, let's define kinematics and dynamics real quick. So kinematics is just observation. You're just watching something and you're trying to predict future motion based off of what you're seeing. So in other words, let's say you're a dragonfly and you see a fly, flying in at some angle. You're going to look at how fast that your target's moving, and you're going to adjust your angle and how fast you're moving to intercept them, right? So you're just making assumptions of, you don't care about the wind or how much what the dynamics are of the situation, how much force is involved. You're just looking at trajectory and predictions of future motion based off of that. So that's all that matters there for kinematics. The kinematics means measurement and prediction of motion based on the future.
Right? I know how it moves. I have no idea why it moves versus, hey, I know why it moves.
Exactly. All right. And then dynamics, of course, would be introducing the causal mechanisms as to why. So that would be like, okay, we're going to take, how fast the dragonfly flaps its wings versus the air resistance, like, the friction, that kind of stuff, to produce the speed and all that. Like that's not what they would be doing here. What they're doing here is just observation of periodicity. So Kepler's first law, to cover what that means in relation to how they're going to derive distances for everything in the sky based off of their periodicity, is that the orbit of a planet is an ellipse, and the sun is at one of the two foci. And what that means here is that the geometry of an ellipse is defined by two foci points here that are equidistant from each other around this curve. And then he's saying that the sun will always be at one of these focus points, and everything will orbit around that for our elliptical orbit, rather than being in the center of it or something like that. So Kepler's second law is that a planet sweeps out in equal areas in time. In other words, the planet moves faster when it's perihelion and slower when it's aphelion. So we could look at this orbit. So that foci point and the remaining equidistant from it, this is how it's going to, that change in speed is going to allow that, allow it to remain equidistant from it. All right. Kepler's third law. The square of the periods of the orbits of the planets is directly proportional to the cube of the semi-major axis of the orbits. So again, that was talking about how they're going to turn, how long it takes something to complete a circuit in the sky and return to its original position, into getting a distance out of it. They're going to use a little math there. Go ahead.
I say p squared equals a cubed is how that's usually represented, right? When they go the derivation of it, that's the proportionality represented.
Yes, sir. Yes, sir. All right. So to start us off with gravity and centripetal force and how they're going to relate this to Kepler's laws with periodicity, we're going to take the centrifugal force, which is Fc here, and this is equal to mass times the square of velocity over a radius, and this will give you your centripetal force here. So our centripetal force is equal to the gravitational force there. So Fc is going to be equal to Fg, and then we know Fg is going to be equal to gmm over r squared. Now this relationship was applied later, which Shane is going to get into, or how they establish these constants rather. But let's just take it for, let's just say they have these constants, and now we're going to relate them to what Kepler's laws are for how things move in the sky. Okay, so the centripetal force here is equal to the gravitational force here, right? Because Fc and Fg are equivalent. So as we're going through this algebraically, we're going to reduce them down into into the smallest form that we can, and we're going to show that the mass in the equations cancels out, and none of this is actually dynamic explanations of anything, but it's all going to be a ratio of periodicities. But we're going over, a ratio of periodicities with respect to constants, and we're going to show how all that relates and what that means as I go through the equation here. So anyway,
Relating centripetal to the gravitational is key too, because that's first of all the circumstances in which the mass cancels out. It's also what they have to do dynamically all the time whenever they use gravitational force of any sort in any circumstance. So it's key that we use it here, and because it's the only instance in which the mass drops out, but it's how they apply it every single time. As far as tides, gravitational interference, all of that, they have to use centripetal and gravitational as the same.
Yep. Okay, so when we start doing the old algebraic shuffle here to cancel out the masses, we can reduce this down. Now we've got velocity squared over r is equal to gm over r squared. We can start canceling out some of the r's here, and we're left with the velocity squared is equal to gm over r. Now we can keep going even further now, and we can break this velocity. So this is how Kepler turned the periodicity into an orbital circumference. So we got this velocity here, and we got equal to gm over r. It's the gravitational potential times the mass over the radius. And then we have, on this side of the equation, we have velocity, which what is velocity? Distance, time. So the circumference is going to be 2 pi r, and then the time is going to be the periodicity of the orbit. So now we can start getting like geometric properties out of this. So now v squared is going to be equal to 2 pi r over the periodicity squared. Now what we can do with that is we can rewrite that as 4 pi squared times r squared over the periodicity squared is now equal to gm over r squared. So this is how we turned a velocity into the radius, or a portion of the radius rather. All right, now we can get rid of these r's. So we can multiply by r's to cancel them out. When we do that, we are left with 4 pi squared times r cubed over over t squared is equal to gm. And we can divide these out to get rid of the 4 pi's. So we can keep this going. And then we're left with the radius cubed over the periodicity cubed is equal to gm over 4 pi squared. We can invert that and rewrite it, cancel out the r's, and then we're left with just the periodicity is equal, or the periodicity squared is equal to 4 pi squared over gm, which is equal to uh, the cube of the semi-major axis, the radius. So all we did there is change how long it takes for something to complete a circuit in the sky into a function of what would the distance be if it was traveling, and how fast it would have to be to get that. So that's why when you that's when you go through and cancel everything out, when we were talking about the mass canceling out, right? The important factor, that dynamic cause, isn't relevant. This is all just a ratio of the periodicity. The only things that change in this equation are the periodicities, because what you're doing for periodicity. So how'd they get the distance to the sun to the earth then? Well, we'll go over that in a second. But the only thing that changes in here for each scenario when you're analyzing how long it takes for something to complete a circuit in the sky, whether it be the sun, the moon, Jupiter, the Jupiter's moons, etc., all of that is that's the only variable that changes in here. So because everything cancels out and it's just a ratio of constants over the periodicity, that's why these work out proportional. That's why when you apply Earth's mass and you can backwards derive what the sun's mass would have to be, and then you use the sun's mass as a constant for everything. That's why all these things all work out, because it's only based off of the periodicity. Everything else will you can backwards fill in. Once you have the initial baseline constant to use, you're good to go. So Shane's going to be breaking down specifically big G and M, which is in relation to Cavendish. But like I said, we're just going to assume these constants for now and say, now that we have them, what do we do with them? How do they work? How does everything apply? Right? Because what if the mass of the Earth is off or whatever? Well, it doesn't matter. It's still going to share the same proportionality ratio. The calculative values of everything else is just going to change proportional, and it's still going to work out. So it would have been whatever they told us it is. So is there anything? Is there anything? Yeah, is there anything you want to add to that, Shane or Zach?
I think did a really good job breaking down what is important is not what they say it is, right? The constant that determines the ratio based on a density inference that they measure later is not the important part of that. The thing that they use it for is periodicity and then the constant. So they can replace it and they can use that same formula for, say, building the solar system, right? Just because they don't know how all bodies interact together and they mathematically can't figure it out because it's impossible, doesn't mean they can't play pretend and then do like one simple series of two body problems at a time so that they get like, the sun and Venus, the sun and Jupiter, the sun and Mars, the sun and Earth, put those in a neat array and go, look, we've used Newton's law of gravitation to build the solar system. And in reality, none of that works. The masses aren't real. They actually would cancel out. They have no actual way to determine the stellar masses of anything except for the algebra that we just went over, including the derivation of Newton and Kepler's third law. And then they use algebra to plug in those masses. And then they use that algebra equation to be like, look, now we can calculate the mass of the whole world. And it's insane and it's never worked. And it's, of course, when the mass cancels out of the equation itself, how can it, one, be the dynamic cause of everything and also be the standard candle from which you weigh everything in the world?
Well said, man. Well
And they
said.
seem to get away with it because the math looks so daunting and hard, right? Because they use all these letters and all this stuff, it's not actual numbers that they're, portraying.
Ratios work, right? So
Yeah,
what are we
ratios
going to
work.
do?
Exactly. It's a way to describe something that you're seeing, not what's causing it. And that's it.
Yeah, they built all of cosmology off of it. Off of that, trying to relate what they measured on the ground and applying it to the sky, and then having dynamic causes. I mean, like the amount of power that they gave them philosophically to people. I mean, imagine you could look up at the sky and go, not only can I predict where that's going to be, but I can tell you how
I'll tell
much
you
it
why.
weighs. Yeah, and they're like,
Yeah.
what? Why?
They've gone way beyond that. Now they're saying, do you see? Well, you can't see it with your naked eye, but there's a star out right here, 2,000 light years away. and it has helium gas going around it, around that planet. They'll tell you what gases are on these planets that you can't even see with your naked eye.
Yeah.
It's nonsensical.
The proper historical context, though, is Kepler had observable laws from making observations. He could tell you where everything in the sky was going to be and when it would be there. And then Newton came along and was like, "Oh, interesting work. I see what you did there. Have you heard of centripetal force? No? Well, guess what? Gravity actually makes everything one. Here's some mass. I'll put it in the equation. Did you see my algebra? And then there you go. That's the historical context for what we're showing you is that's how Newton came along and solved the problem of the dynamic cause of everything. Right? Crazy.
And all
Yep.
Kepler did, like an analogy to that would be like watching a movie and then watching a movie with someone else and telling them the ending.
Like, or that I wrote the ending and here's
Yeah.
what's going to happen.
Here's what's going to happen. Yeah, exactly.
Yeah. So a few more things to note on the solar system and the mass of the sun. So everything we know that how they calculate everything is you can basically ignore this is how they solve the three body problem, right? For one of the ways they'll say is that you can ignore the mass of everything else because it's not going to influence anything over the mass of the sun because it's so massive. So everything in the solar system, where the mass cancels out in the equation and it doesn't affect it at all, you can you can, they say that that's because of the mass of the sun, right? But when you put the mass back in the equation, it changes it by an imperceptible amount. It's 0.1%. You're not gonna, for an orbital circumference of, or they'll say that that like Saturn is 800 million miles away from the sun. Okay, dude. So there's a 0.1% difference in that if we put the mass back in. Okay. Well, I'll be sure to. Well, man, you really convinced me now. It doesn't. They're like, we can solve a Lagrangian and it'll change the. Okay, man. Yeah, but can you really? Does that matter at all? No.
You don't know what negligible is by telling me you don't know what negligible means.
You're right. You tell me you don't know what it means by reiterating it like it's a big difference. No, yeah, that's exactly the point. So you might hear something like, what if we add the masses back in, or you need to solve a Lagrangian, do it, and then like tell me the difference and like let me know how we're gonna confirm that. Like you can certainly calculate it for sure, but in terms of explaining where that thing is gonna be a year from now, you don't need to Lagrangian it. You can just use the periodicity that everyone else used, so it's fine. But they do like to play in their Cartesian coordinate system and act like they can pick out any defined point in three-dimensional space as defined by their coordinate system. So that's a lot of fun for them. So anyway, we'll get back to showing this relationship again, just to kind of reiterate the points here in a more visually aesthetically pleasing manner, perhaps one would say. I would say that, but I'm biased because I made it.
I love this one. Yeah.
All right.
Say it.
So we got our starting FC relationship for centripetal force. And this is, of course, equal to the gravitational force, which is going to be equal to GMM over R squared. And we got our pi in there, but you can reduce that out and just anyway. So this is good. So our periodicity is going to be equal to our semi-major axis cubed. Now, what you would do here, say perhaps we have a guy with some lead balls in his shed, right? He measures the gravitational potential difference between the Earth and these lead balls. And with that, he can algebraically derive what the mass of the Earth would have to be to create this gravitational potential difference. So now he's got a constant here for the gravitational potential. Now he's got a way to derive a relationship between two masses of different. Let me move this. See if I can move this. Nope, it doesn't move. So now we could take two masses, and we could see what the gravitational potential relationship is with them. So we're going to take Earth, and we're going to take the Sun. We don't know this m, this little m. We don't know it, but we know the big G because we did Cavendish, and we know big M because we can backwards derive it from Cavendish for Earth. Now we have the periodicity of the sun, 365 days. We just square that. We'll turn it into seconds and then square it. And then now we have our square of our periodicity of how long it takes the sun to complete a circuit. Oh, and what do you know? That's proportional to the cube of our semi-major axis. So there's our astronomical unit.
Right? Yeah.
Oh, and then also algebraically, we also just learned the mass of the sun now, what that would have to be to produce this based on this relationship at these distances. So now we can, from Earth, from our position on Earth, we can watch Mars complete its periodicity around the sun from our perspective on Earth, right? We haven't gone to Mars yet, or I'm sorry, Mercury yet and measured it. We haven't gone here and measured it yet. We've just watched it in the sky, right? But now we can derive its mass relationship based off of its periodicity. Because none of this actually matters, and it's only about this periodicity and that.
That is how they got the AU, though. They really just used Kepler's law, used an observed orbital period, right? Used parallax angles to supplement that to get some detail. Finished it off with, quote, Earth's radius, which of course they knew. And that's how they get the AU. So without the Earth's radius, they actually have no AU because all of it is based off of ratios and constants, right? So to get an actual real world metric measurement, they had to plug in a real world metric measurement, and all they can ever do is the radius. And where do they get the radius, everyone? Well, from staring directly at the sun straight from Eratosthenes. So no Earth measurements required. Everything is just based on observation from Kepler, essentially.
Yep. And now we're going to watch Jupiter from our earthly position, and it's going to complete its periodicity around. And now when we're looking at it back in the same spot in the sky, guess what, boys? We now know how much Jupiter weighs. And the same thing just applies for everything. They did the same thing for everything. And because of the mass
Now,
of the
why
sun,
did they make Jupiter so big?
well, they didn't make it anything. That's what it calculates out to based off of its periodicity in this relationship. So this is what it
Couldn't
has.
they have just
This
said
is
it
what
was
it. This is what.
smaller and solid
This is
instead
what
of
it.
gas?
Well, what it weighs and how big it appears, angular size wise, doesn't matter. So, like the story that they tell us of what it is made out of is just how they can explain how much mass has to be there for what it has to be, right?
How big it looks, right? Optical diameter is all they're using. So
Yeah. So none of that matters. Like they don't know that Jupiter is made of anything, you know, or any like they'll say things like, oh, it's got a liquid hydrogen structure and all that. Like they don't know any of that based off of its gaseous structure or anything. All of that mass relationship just comes off of its periodicity. None of these factors matter. It's all periodicities in relation to the original constants. So that's why,
Crazy.
yeah. So the longer something takes, it's going to have a different mass.
crazy, right? Everyone should be shaking their head. We've all been bamboozled. They really put one over on us with this one, right? Like, look at all the stuff we know because of like our physics guesswork based on the observed periodicity of things in the sky. Like, what if you framed it like that? You get laughed out of science, but people who specialize in this theory get awards, and people get like revered. Like, oh, you're a master in guesswork. Have a degree.
Yeah. And now this only works like in our solar system basically, and it doesn't even work that well because of the perihelion precession of Mercury. So if this relationship, because there's multiple problems with this whole model, and you can falsify it different ways. But one of the issues that they were having back in the day, why the perihelion precession was so important, for example, is when you're in these elliptical orbits and gravity is the causal mechanism. When you're perihelion, you're locked into your plane of orbit. You can't deviate. There's no wiggle room to like have a perturbation. So if you were doing that, then the causal mechanism isn't gravity, right? So that's why it was important for Einstein's theory to be backwards compatible with with the gravitational theory, and like it just barely calculates this missing difference based off of space-time curvature rather than gravity as like a mass attracting mass mechanism. And that's why they were like, well, at the more refined precise level, you have to use these calculations which are based on these previous calculations which are supposed to be physically meaningful. And they're absolutely not, because these equations not to skip around too much, but this 30-kilometer velocity mandatory thing is in relation to how fast the Earth would have to be moving to complete its periodicity. So when they like all these masses correspond to a velocity as well because you can derive how fast it's moving off of that just algebraically. And when you have that velocity relationship, all these have to be moving at specific speeds. That's why Michelson-Morley was so important. When they didn't measure that velocity, when they knew that they could use the wavelengths of light and the separation and the phases as a relationship to actual velocity, and they measured a velocity that didn't match what they had predicted, their whole world was turned upside down. They lost everything.
That's why Einstein, the Earth movie, came in to save the day and was heralded around and shepherded and not allowed to debate. Nobody could critique. Anyone who who disagreed got destroyed and discredited, etc., etc.
Yeah,
You go.
every
There's that's when you put the mask back in. You found that snippet.
Yeah, and in
I
relation
love.
to the sun, and it's like, yeah, so an example was given to me in conversation the other day that was like, well, when we apply these equations, they're physically meaningful. And it's like, okay, but when you apply them in the solar system, the mass cancels out because when you put it back in for anything, it changes by 0.1%. So it doesn't matter. It doesn't actually mean anything. And when they get to um like galaxies and stuff, when they found that the galaxies were rotating so fast that they would rip themselves apart because the mass based off of their luminosity that they had calculated, another way that they derived mass for, or like the mass distribution of a galaxy rather, was off based off of how fast it was rotating. And so that's where they came up with dark matter and dark energy to supplement how much their gravitational predictions were off, because none of this actually means anything. It's just ratios of things that
Oh,
they've established.
dude, they do the same thing when they actually calculate big G and get that constant. It's off by so much that they also blame dark matter and then a molten iron core. They're like, well, it fluctuates right by up to 80%, but we're still right.
I
It's
saw an
crazy.
article they were talking about there has to be dark matter in our galaxy here. There has
Because
to
we know
be.
we're moving, we know the Earth's a sphere, we know we're not at the center. All these things we know, therefore we know dark matter is real.
Out there. That's crazy, dude. So a big thing here is like the reason for all this too is instead of like admitting that there's an absolute space and the earth is at rest, and you can treat the earth as actually at rest and just not just for pretensies, is a lot of this was to remove that concept and keep the idea that there is no absolute space. So that's where they're like, oh, you know what? It's actually time and space that are bending and warping. And like, how did we get there? Well, we have to assume the mass distribution of the universe, but like, trust us, there's no rest frame or or anything like that. There's no preferred frame, but we know the mass distribution of the universe to do our calculations based off of no preferred frame. Like, pick your poison, I guess, right? So, Shane, did you
When
want
did
to screen
Venus
share?
come into play?
Venus. That came
I
into
know
play in
Venus.
substantiating the distances for the astronomical unit, which Shane has an excellent breakdown for as well, because all of that is based off of just optical relationships and assumed angular size. I'm sure you've heard that Venus is miraculously the same size as Earth. Guys, did you know that Earth has a twin in the sky? Did you know when you look up at the sky and you see Venus, there's a little Earth twinsies. They're the same size. They have the same radius, guys. Go figure. So Shane's gonna go into all that. It's
Yeah,
hilarious.
some dude named Huygens, I think, was like, "Oh, we got to solve this wonderful problem by just assuming that it's the same size, and then using the basic same periodicity and observe Kepler's laws. We could be like, oh, well, now we know the distance from the Earth to the Sun, but it's all just a product of the assumed radius, like I said before, which is just a calculation from a quote measured circumference, which is just looking at the Sun. That's crazy. I think we want to do little G and big G real quick. Little G is probably one of my favorite
So
things.
they started with the sun and ended up by telling us how much the sun weighs and using this telling us how much everything weighs in relation to the sun. Nice. From the earth.
Well, that's the distance, right? The distance from the Earth to the Sun, and then they measure everything else in the solar system. And well, how many Earth-Sun distances is that? Right. All right. Well, 2, 3.4, right? And then they just get to develop their own ratio again. So they developed a unit and then made it one, right? And then everything else becomes ratios of that. Whatever.
Your screen share is
Love
not
them
working, sir.
ratios.
You might
It
need
is
to
not?
redo it. No, it's just infinite loading screen.
Working for you, Zach?
I am seeing it. Yeah, I'm seeing it.
Yeah, I'm seeing it. Let me try something else. Let me do just the whole screen then. Is that better? Does that help at all? Did that change anything?
Negative, Ghost Rider.
Okay. Change windows again. What if I just do the whole screen then?
What if you
Usually share everything full
end the current session and start a baby fresh one? See if that changes it.
I like the sound logic where I change nothing, but it still fixes itself.
Yeah, it's the old. It's the old. My computer's not working right, but when I rebooted it, it magically is all of a sudden working.
Okay, unplug it. Plug it back in. All right, you fixed it.
99% of the
You
time,
guys are too young. But,
works every time.
Back in the day, we used to blow into the cartridges. Nintendo's.
Oh, dude,
Oh, that
not
still works for me.
too
I
not too young
appreciate
for
that
that.
metaphor. Yeah.
Yeah. You think your boy
You
didn't
see it
have a
now?
special way to rinse the PlayStation disc to make sure that it worked? There's a protocol, guys.
My buddy be licking it. Oh man.
Do you see it now?
Negative.
Oh my god. All right, how about now?
Oh, are you on Vencord?
Oh yeah. Let me
The
go on
issue
Discord.
the issue is you. Yeah.
Yep. Hold on, I'll be right back.
All right. We've narrowed it down to just Shane.
Yeah, it's amazing how many years and how long it's taken them to get their lies straight, and they're still like horrible at it.
Dude, they've had like 700 years in like unlimited funding and media propaganda and indoctrination, and we get like a couple of things wrong and people are like, yeah. it's like guys, we just work here. Like
Just dudes that read PDFs on the internet.
all right, I got you pulled up on the big screen there, Shane.
That fixed it immediately. Okay, that's cool. Yeah, Vencord doesn't share well. I remember that. Everything else is much better though.
Yeah, webcam is off though.
Oh. Right. Good to go. Right, so little g, start with that on the left over here. This is like the kinematic formula where you can derive little g. So they always say that little g is because of big G, right? Dependent on it. I haven't found the math where that makes that true. I found the simplified version that makes it specifically not true, where you can, independently, when you simplify the equation for velocity at 0, you get, a, or little g in this case, just equals 2 times the height over the time it takes to fall squared. Right, that's the most
So when
basic derivation of it.
Yeah, when you say kinematically derive, like what do you mean there? Is that you mean you're just making an observation of how fast it takes for something to hit the ground?
Yeah, the only
And-
requirement
and-
to get
and
that constant is those two things, right? To the height from which you drop it and the time it takes to hit the ground.
and that's just a ratio then.
No, it's from this kinematic formula actually, where h equals 1/2 AAT squared, which is the height times 1/2 the little a times the time squared. But when you're simplifying it to solve for little a, it comes out to 2 times the height over the time it takes to fall squared. And then
Nice.
to prove that, you can do basic math over here, right? And say you have a ball, you drop it from 20 meters, it takes 2.02 seconds to fall. Things you can do with a stopwatch, right? And you can do it right now. And then you can just use this formula, plug it in. A equals 2 times 20 over 2.02 squared, which is 2 times 20 is 40. 2.02 squared is 4.08, which when you do that ratio right on the spot, 9.8 meters per second. Oh, wow. So it's almost like that works no matter the shape of the model that you're trying to prove. It just is in physics, 101, it's how you would solve to find the acceleration for which things fall. There's a couple other examples here, right? From height from 15 meters, and it takes 1.75 seconds. You do the same thing, comes out to 9.8. Do it a little bit more with real life. Say you drop it from 50 meters up, way up there. It takes 3.19 seconds to fall. Do the same math. 2 times 50 over 3.19 squared equals 100 over 10.176 gives you 9.83 meters per second. So little g seems to be largely independent of big G from this basic math, right? And we're just doing physics. You're taking measurements of how long it takes things to fall. So that's little g in a nutshell, essentially. Any questions on that?
Yeah, so whenever you see G in an equation, it doesn't necessarily mean a mass attracting mass relationship. It's just describing the actual acceleration of an object or
Yep,
what
you
it's
could
going to be
easily
experienced,
swap out.
the force that's going to be experienced.
Yeah, it's the acceleration, right? So they could say the acceleration due to gravity is over here, but it also equally could apply to any other force for any other force equation, right? So we could easily solve little g and swap out for little a just to call it the acceleration. They call it like, oh, g equals gravity, but a could equal acceleration. That's really just nitpicking. Algebraically, though, you can always solve for this on the spot. So like without any gravity, there's no gravitational constant. There's no earth mass in here. This is just how long did it take to fall? How high did you drop it from? Here's what the acceleration would have been in this force equation. So that's
So
little
really,
g.
that's all we really need. We don't even need a little g. Little g is just making up some excuse for
It's
why A happens.
Yeah,
yes,
so
little G is
I
just the
would
variable
call
output.
little g the kinematic and big G the dynamic, right? If we're gonna categorize that, right? Because they claim to know what big G is and how they got it was gravitational forces, quote. But little g is just kinematics, right? Observable, repeatable. You know where it is. That's all it is. There's no dynamic cause required for that. Because we can easily say little a is because of electrostatic downward acceleration and has the same corresponding variance by latitude as your said proportion of mass attracting mass that big G does, right? We can say that. So the dynamic argument is still there. This is just the kinematic observation, though, as far as I can say. So then, speaking of big G, right, we can go right into that. This is just a quick breakdown of the math of how they got it, right? So they started off with Newton's law of gravitation, which we've been over. F equals big G times m1 over m2 over r squared. And G is the proportionality constant, as we were going over earlier. And then when you're going to solve for the gravitational constant, you
real
just
quick,
use algebra.
real quick before you solve that, what's the M in those equations?
Masses.
And how do they get
Masses
those
m1
again?
and m2. Well, they used pretty much Newton's third law from Kepler's third law, and then they rearranged the equation to solve for arbitrary masses. Yeah.
No, I'm sorry. For Cavendish, the mass of the balls is just derived from downward acceleration, little g, like little a.
Oh yeah.
Mm-hmm.
What do you mean?
The mass of the ball, like how much it
For later?
weighs.
Yeah. Yep.
Yeah.
Yeah, that's when you start getting into the mass equation, the weight equation. We start rearranging for little g and swapping in little a. It's all the same stuff, but yeah.
Yeah, so
when we're
like
trying
just
to,
like this equation, just like it looks like it's like been redressed in like some way that's like, oh, balls attracting balls, but it's just like it's not it at all.
yeah.
Things
Yeah.
fall at a certain rate.
But
That's
this
what-
is the form that they had to use to get their constant to backwards derive into this, right? Because that's what it's all about, is to get the constant that makes everything work. So they had to use it to get it, so they can use it to get it in the future, right? So they used two small lead spheres, M1 over here, and then a horizontal rod, and then two large lead spheres with M1. So if we go over here, essentially the trick is that at the end of this equation, there's actually two unknowns, and that they again solve it to mean a ratio of those two without ever actually getting an empirical value for what they're trying to solve for in the first place. So when we're using the torque balance, they related it to the gravitational force between big M and little m, causing the rod to twist. So they define that force over here, where L is the rod length, and then they're saying that this wire, which resisted the twist, is restoring torque, and they have the torque of this wire equals this is another unknown, right? And then they have K is the torsion constant of the wire, which is saying the angular displacement. And this is what it would be at equilibrium when they're using the formula. Again, they're trying to solve for this unknown. And what they have is an oscillation period, which we're going to go into in depth from Michael Brenner. To determine K, they measured the oscillation period T of the torsion balance. supposedly they measured this, and again they're calculating it and solving for k again, and that they ended up with this mathematical expression at the end, which when plugged in, of course, would give them, as we went over here, big G with the 4 pi squared times the mass of the length of the rod squared over 2 times their angle of the torsion times the radius squared over their periodicity squared times the length of the rod times the mass of the big ball, the mass of the little ball. But what the major magic took place over here when they're trying to solve it with proportionality, and they still, like I said, have two major unknowns. So they're going to ignore that. They're going to solve it. They're going to plug in what they already know from their other things. They say, look, we have the mass of the sphere. We have the mass. We have the oscillation period, even though this has never been actually isolated. We have the oscillation period. We have the distance between the two sphere centers, and we have the angular displacement theta in radians. Cool. They plug that in. They get what they had set out to find. The 6.67 times 10 to the negative 11 meters cubed per kilogram a second squared. Or however you're supposed to say that. When we get into what does that mean, though, right? When they determine this and how they got this, like, what does that mean? So this is taken from Michael Brenner, who did a really good breakdown of the scientific and sort of implications of Cavendish and supposedly solving for the mass of Earth via a density inference. So it says because the Cavendish is at the fulcrum of this disastrous development, he's talking about the development of scientism. Says we need to have a close look at how it went down. So he said that they use what's called a torsion balance, where a deflecting force is brought into balance with the torsion of resistance of a wire. And the deflecting force, which he calls F, which we looked at before, is the gravitational attraction between these two lead balls, and one is on an active load arm, again L, resulting in the torque F times L, which needs to balance out with the torque of the torsion resistance K. Now again, we're trying to solve for that torsion resistance variable again, and he notes that at equilibrium, when the balance has been stabilized, the total amount of torque must be 0, as the two sources of spheres cancel out. So what his point is the first big issue with this whole setup is actually the rod was never at rest. Cavendish had to measure the deflection angle of the rod while it was oscillating. And so the real life analogous experience for that would be, imagine buying a fish at the market and the vendor is naming you a price while his spring balance is swinging around. Right? He hasn't actually teared it. It's just bouncing everywhere. And he's like, it looks at about whatever that highest margin was. Right? You'd be like, get the hell out of here, and you'd walk away. Yet, when Cavendish is trying to measure out his torsion rod and trying to measure this tiny, minute deflection angle to infer the density of Earth, we allow him to do it on this wild, swinging, oscillating thing, which has never been balanced, right? So it would never balance, as Brenner's argument says, that it is not balanced and it would never be balanced, which leads to the next big issue, dampening. The twisting of the wire has to overcome friction, which is the prime dissipator of energy. Anything that is gravity driven only has a very limited amount of gravitational potential energy to be dissipated, which would happen very soon, right? So he's saying that also wouldn't happen. The other objection that you can raise is that typically torsion balance are done in a vacuum, because you have a hard time discounting, a hard time air displacing in a gravitational acceleration of 9.8 meters a second squared, which we derived earlier. Yet we're to believe that the acceleration of 0.000007 meters per second squared can displace the same density of air with balls of a combined area of 40 centimeters squared. So, and that's why real precision torsion balances are housed in a vacuum, and Cavendish balance was, of course, not. And then he said, they determined the attraction between the lead spheres at right angles to the direction of gravity. Now, without getting into the geopotential model of the geoid and how gravitational vectors work and how it needs a perpendicular relationship to that vector at all times regarding plumbobs and the levelness of plumbobs, but ignoring all that, he says by doing so, you can eliminate from consideration the gravitational attraction of Earth and deal solely with the attraction between the spheres. Say what, dude? Wait, what? So determine the attraction between the lead spheres by discounting the hugely, the much larger force of gravity. We're just going to discount that and say everything that's left is obviously the gravitational force of these two spheres. Wow. Anyway, it says that this is apologetics physics, right? That's what he says it needs to be. You need nonsense apologetics to hold up nonsense results. So the combined mass of the moving lead balls add to the unaccounted for masses of the rod and the wire to multiply by 9.8 to give you the stretching force on the suspension wire, and then the stretching force change to the resistance of that twist by increased friction. So that's the original torque that we were talking about from this original torsion balance. He says the consequence is this experiment would give different results on the moon, again in null gravity points, again in vacuum, and a combination thereof. So there can be no question of the universal constant being the result of such an ill-conceived experiment, which leaves out the equation all gravitation noise of all the four balls would only be the only masses in the universe, right? So tears that all apart of all the variables having any scientific correlation, discounting the mass of the much larger Earth, not doing it in any sort of controlled vacuum. Anyway, again, the biggest point says this is purely procedural, and already we have a scientific freak show. Because what about the math? He says pure Copperfield. I really love this guy, so I'm going to read it. I'm going to read most of it. Michael Browner, you should check him out on Core if you haven't. He has a lot of great breakdowns. Says we're sitting there oohing and eyeing and not looking closely because we've paid for the show. We might as well be impressed. That is overall the scientific consensus. It is claimed that from the balance of k times theta equals the force times L, which we saw never balanced anyway, we can derive big G via the force of F equals G times M over R squared, which he does some simplification. He says the problem is that we have two unknowns, K and F, right? The torsion and the force. And therefore, the best we can hope for is that this equation give us a relationship. Theta over L equals F over K, meaning I can get the same result for any F and any K as long as the ratio equals. And he says, and here's the Copperfield, a mathematician, to get the inattentive, gullible public, which includes PhD doctors, by saying, oh, we have a measurement in the oscillation period which gives us K, and then we have a value for F. Look, behold. And boom, we are duped, right? So he says that by using this equation and solving for two unknowns to only get a ratio, and then plugging in a supposed known elsewhere to get this supposed force is not is not proper math. It's not proper physics. It's not science. It doesn't give you anything, and it's a big bamboozled job that he says they ran over on the whole public, and that's his position, right? So it doesn't prove the mass of Earth. This is flawed in its entirety. But what they started with was a ratio, which of course works, as we said before. So that's why that they can move on and say, oh, look, we've determined the mass of the Earth. And that's how they can plug that in to use for all the stellar observations and try to guess the mass of planets and Jupiter and all that stuff based on this experiment and this measurement. Kind of crazy. Go a little bit further. He says you cannot determine the torsion coefficient by the wire, by the force you want to measure it with, right? Because that's what they're doing. Remember, the two unknowns were the torsion and the force, and they're determining the torsion via the force. So instead of determining a final ratio of relationship with your unknown variables, they're saying, hey, you cannot define the torsion coefficient of the wire by the force you want to measure. And that's exactly what they did. I thought that was such a good way to put it. You have to know one of them independently. And because the whole setup was built to find F, Cavendish would need to present a painstaking independent research into torsion coefficients of wires, especially the wire used, none of which ever happened. He finally goes on to say the next step is the interpretation of the experiment, which so far has been nothing but a scientific and mathematical ghost train. He said for interpretation, Cavendish did this 2,000 years and grabbed an arbitrary number derived from a similarly unscientific approach, meaning Eratosthenes, right? Eratosthenes, when he looked at the sun, determined the distance based on parallel sun rays, postulate them to be parallel, and a known diameter of Earth because he used 800 kilometers between Syene and Alexandria, and he used, I think 7.2 degrees, so over 360 times 800 gives him 40,000 kilometers, and that's how he determined the circumference of the so-called Earth, right? So this circumference value is also what is plugged in to get the overall density of Earth once they know it, because they know the big G, right? So they can use the known circumference, and they can get the actual density of Earth over here. So speculative diameter of Earth plugged into the math of the Cavendish, and output came for Earth's density, right? And then he says, but we observe and measure the density all of Earth. Sorry, do you have a question?
I was just going to say, regarding Eratosthenes, is there any ancient writings that mention his name at all?
No, full on
I
fake
know
Greek.
there were,
Yeah.
yeah, there were Greek mathematicians at the time that wrote books, right? And he's supposed to be like some superstar. That's like writing about the championship Bulls of the early 90s and leaving out Michael Jordan. Just not mentioning him at all, not even a footnote. Just he wasn't even there. It's insane.
Yeah, you're right, dude. I like to entertain the I like to entertain Eratosthenes and the other fake Greeks and stuff like that.
Oh yeah,
But
we can give it
reality,
to
you're
him.
yeah, like you're
Yeah.
right. There's no historical record. The only evidence they existed was other fake Greeks that said so. And then when it comes down to it, it's like, but there was a book that we had that proved it all, but it burned in a fire. But you have to trust us. And then it comes down to, well, everyone is actually mentioned in Herodotus, who's like the father of oral history back down through the classics. And, you got Hipparchus and all the fake Greeks who all invented everything that everyone needed. The only evidence are each other. So as far as I can tell, if you can control Wikipedia, that is all the evidence for Eratosthenes that there ever has existed.
But
But
yeah, I'm
anyway,
with you. We can give it to him. It's
I
not.
usually like to play in the weeds with them on that one. Yeah. So Brenna was talking about how the only time they get anything meaningful out of this equation is to infer a circumference, again measured from assumed parallel sun rays, and then you get the radius of Earth, which to plug into the actual Cavendish to get the supposed radius. So that's insane, right? That's all crazy. And he goes through it to say, actually, there's discrepancies, right? If we observe and measure the density of Earth, we get a discrepancy of 80% between calculation and observation. What is the solution? Double checking our experiment? Hell no. Invent an inaccessible and non verifiable iron core to supply the missing mass, make the discrepancy go away. Pretty much routine, right? He compares it to unverifiable dark matter and dark energy, right? Because he says pretty
Yeah,
much the same routine
dude.
later when computations based on big G leads to a 97% discrepancy, which can be compensated for with inaccessible and unverifiable dark matter and dark energy.
Yeah, Zach, that's what I was talking about earlier when you asked about Jupiter, and they were like, "Why does it have to be so big or made of this?" And it's like, doesn't matter. They'll literally tell you what's inside the core of it to invoke the missing whatever they need.
Yeah,
Like,
whatever
dude, did you
they
know
need.
Jupiter's only 3 ounces of helium, but the core is 95 gajillion kilowatts or whatever? It's like, oh, okay, cool, got it, dude, got it. Insane.
Dude, over here's what it should have looked like. He said a torsion balance used by Coulomb to measure the electric force, right? Negatively charged ball tracks a positively charged one. He did the actual torsion balance in a vacuum, pinned it, controlled everything, and then he came out with results of dynamic situation where masses aren't at rest. But that was just for comparison. Everyone should check out Michael Brenner, dude. The dude's a beast. He talks about a lot of the stuff that we talk about. I don't think he's a flat earther or pretends to be a flat earther, but he answers all the flat earth questions. He says, so if you don't have a stable reading for theta, you have nothing. Right? This was his back to the equation where they were determining the ratio because they had the force and the angle of torsion, but they couldn't independently verify either one, so they used one to solve for the other. Big no. So if you have a stable reading here, you have nothing. And he says this overshooting is directly referenced in the result. The calculated density of Earth is 80% higher than the actual measured density of Earth, and he sort of drew it out, and then they sort of solve it with an iron core in the equation for a sphere. But that's all I had on deriving and the misapplication of the Cavendish to get what is not big G.
Oh, dude, did you know that the iron core makes up the missing mass of the Earth for the density? So
Just
that
what
we
we
so
need to.
so that we can all pretend that it's even a tenable position to measure Earth's velocity through space.
Crazy.
Absolutely incredible.
And the real rub that gets me the most? It's not so much, well, I mean, I don't like to lie at all. It, it but the brain power. All of these super genius children that have these exceptional capabilities, and they end up going to school to study this stuff. We could you imagine what this earth would be like if all that brain power were put towards something real and not Narnia?
Dude, they literally corral the smartest people and get them to focus on fake BBs partaling around everywhere so that you can understand the universe. Like, give me a break.
The old fake BB story gets him every time.
BBs bouncing everywhere, little energetic BB particles that make up everything, dude, that are constantly interfering with each other because we know where they are, but not precisely where they are. We know about where they are via a probability equation, but we know they're there. So yeah,
that was
dude.
awesome.
Big G, little G, kind of our favorite things. Little G is independent. Big G is just a contrived mess based on an observed torsion, right? So they're inferring a force based on the torsion, and then they're just solving for two variables and then pretending that they know which one is to get the other and behold density of Earth, and then backwards compatiling that into every astronomical observation. Literally, it's
So could you
every.
say little g is just the rate at which things accelerate towards the ground?
Yep, that's exactly it.
That's all it really is. I mean, you
Yep.
could just use little a acceleration in
Yep,
place of
which
little
is
g.
which is what I did in the beginning when the Globos were like, "You need it," and I'm like, "No, watch." They were like, "That's you're tricking me. You just used A," and I'm like, "Yep,
Yep,
that's what I did."
that's all we needed.
That's all anyone's ever had. It's been a nice trick and ruse that they've done to everyone. But you know, that's now over.
So have you
Yeah.
heard any good arguments from anybody on the Globe side recently? I know you guys are in there a lot more than most people having conversations. Anything that like, grabbed your attention and you were just like, oh, I'm gonna have to think about that.
No, dude. So the celestial theodolite that we've been arguing recently, like everyone's response to it is actually super insufficient, and it's actually a straw man of the position now that I understand it better. They're cooked. It's over. So the only refutations to that, like this dude that just DM'd me, his refutation was to do a bunch of corrections and say that they're the same, and that's welcome to flat Earth. if you're physically moving them, like you can't do it's there, but you're gonna correct for it to be there. It's buddy, your correction now matches my flat Earth uncorrected angle. Welcome.
Look, if it's not there, can I correct for it with math and just pretend it's there?
Dude, he just went through
Yes?
the he just went through the whole thing. And was like, see, you did it wrong. It's like we didn't do it wrong. We have two different predictions.
But you could turn on the atmospheric correction to go back and forth between the two, which I think is what Mike noticed when he was like,
Yeah.
if I don't correct for refraction, it's flat. If I do, it's globe.
The globe only exists as a scaling logarithmic correction from G.G. Bennett.
Right?
Unifying celestial and terrestrial observations with positions to the stars.
That's quite eloquent. We should put that somewhere.
I just got it on a bumper sticker. Nobody knows what it means. They're like, G.G. Bennett. It has a QR code, though, so maybe they'll scan it.
There you go. Spread the word.
Yeah.
I have a bumper sticker that shows a horizon with the sun setting on it halfway down, and then underneath it just says it's flat.
Nice.
I've even had somebody, when I was in Denver, they went and put a little note underneath my windshield wiper, and all it said was, yes, it is.
All right. Do we have any questions about this? We'll open it up to the lads now. If anyone in the Discord has any questions, and I'll send a link to the Discord in the chat. Feel free to join and ask. You don't have to come on webcam, but it is encouraged.
We might make
And
fun
how
of
do
you
they
if you don't.
explain gravitational anomalies here on Earth? They're all over the place.
Pick me. Okay, so here's how they explain it, right? We got our expected position of a star's location on Earth, and we got our theodolite and or telescope. And we're going to stand underneath the star because we know where it's supposed to be based off of the almanac and all that. And first cusp of Aries, celestial navigation, the globe, latitude, longitude system, right? So we know where that star is supposed to be, right? Now, when we take our telescope and or theodolite and or whatever, and we look up, star's never in the center there where it should be, but we know it should be there because we got there by following a cosine of a triangle. So we know that when we look up, it's gonna have to be there, and because it's not, we're gonna need an explanation as to why. Now, we could go with a couple of different possibilities, but if we're trying to unify everything into like a physical explanation, what we're gonna have to say is that for some reason, oops, in this area, all and
Right.
just around me, right when I drop my plug bob, it's actually not going to the center of the ball because there's something in between me and the ball, or the center of the ball, and that mass distribution there is off, and it's causing an anomaly. So that's what they say. That's how it works. That's what it means. It doesn't. No one's got like a gravity thing out, and they're like, "Oh, dude, there's different density here." Nope. They're just looking at the stars, and they're like, "It's not where it's supposed to be. How do I move you from here to here?" Hmm. Okay. Well, I already said that the Earth is curved this much, so I need a little bit more. What do I do? Oh yeah, gravity. We need to be perpendicular to the gravitational relationship, so we're actually off center.
Crazy how that works, man. It's
So
crazy
what
how
I,
you figure that out. Put
it's
it in
one of
layman's
my
terms, and it
favorites.
sounds so silly that you just can't say it out loud. This is your belief, right? Put the disclaimer. This is what you actually believe.
We
Like South
started
Park did for talking about Scientology.
we started a marketing campaign that for beds that are perpendicular to the equigravitational potential of the geoidal model at your latitude, so that you can be comfortable and sleep well, so you don't wake up on the wrong side of the geoid.
If you don't correct for the
Like if you
downward
think
gravitational
that your
potential, it's bad.
bed
Yeah.
is level just because when your house was built, somebody came through and leveled out the basement and built a structure on top of it. If you think that's level, like, have you considered that your angle to the stars might be off because you're actually not level, and you're not perpendicular to the gravitational potential of the geoid? So your bed, while you could put a spirit level over it, yeah, I mean, sure, it's level, right? But is it relative to the stars?
Yeah.
No, you're gonna have to tilt your bed.
The Rick and Morty, where they
Oh
talk
yeah,
You
about
the
experience
true
true level.
level. True level's a classic, dude. Yeah.
you think that you can find true level with the bubble, and that's he just lays into them.
Yeah.
Uh,
It's kind of weird that he
the
didn't
world's a
reference the
lie.
stars when he made it, but that's
Yeah.
how you know it's not
When
actually
Morty
true
steps
level.
on it, though, everything's a lie.
Yeah. Yeah.
Uh, it's okay, buddy. Come here. They're actually going to keep making Rick and Mortys.
Oh, no
I
way.
had to go look it up 'cause it's been forever. I guess they're going through to 2027.
Nice.
And this fall, like maybe the next one will come out. I know that one guy's not going to be there that used to do Rick, which,
You quit?
sorry, everybody. No, he got caught doing bad stuff, so he's gone. I don't. It's not for Glowbusters,
Oh,
but
gotcha.
yeah,
Unlucky.
the show really wasn't as funny as it used to be, in my opinion. I thought, you know, a lot of comedians live on that fine line between, like an alcoholic and overdoing it.
Right.
And he was an alcoholic, and he recorded a lot of the first 3 seasons while he was drunk. Like
Mm.
he was getting drunk in the studio recording it,
He was
and a lot
funnier
of the
drunk, you
takes,
think?
well, he was ad-libbing so much of the stuff, and then they just kept that stuff that he was
Nice.
ad-libbing because
Yeah.
it was great. But again, you don't want a performer that needs to be drunk, to do their job. Bad things start happening, and that's what happened. So yeah, we'll see what it turns out to be. But all kinds of flat Earth references in Rick and Morty, multiple times. There's been flat Earth references, so somebody on the show knows
Nice.
for sure. Like the words flat Earth have showed up on screen.
Nice.
Globe Earth, flat Earth, and then other. Yeah, it's weird. So for what that's
Oh.
worth.
Dude, you didn't did you hand out the Mike made like a link to the place where you can verify it for yourself for the celestial theodolite, and he had an old little applet set up where you can verify it using every known method of metric distance comparison, GPS coordinates, radians, however you want to do it. I think he linked it. I think it's in his press somewhere. Oh, I got it. I'm gonna link it.
But yeah, that was a great presentation, gentlemen.
Oops, I have my mic muted. Yeah, if you check the link in the chat that Shane's about to drop, you can use that to calculate all the necessary information that you need to make your own predictions in Stellarium. And then you can verify the occlusion of the star for yourself, and that will verify the corresponding angle for the prediction. And if that works out, then guess what, lads and ladettes? You
Earth
just
be flat.
you just contributed to globularity. Like I said, this dude, he was like, "Did you see Ruhif's new video? Don't you know the celestial theodolites? He did the math wrong or something." I'm like, "What do you mean?" His contention is that the measurements in air, not that the math prediction's wrong. And then he goes through and he's like, "The math is wrong. Here's how you do it." And he goes through the refraction and dude, if you make your position my position, you're a flat earther now. Congrats. You missed the entire point. Thank you. So
Your
yeah,
position, my position. What an argument.
yeah, great. So your corrected version matches the raw flat Earth one. Cool,
Thank you.
sweet, bro, sweet.
Dude, I'm so
Real
happy
back
about
to
the mic
gravity,
journals.
just real quick. You know, you'll hear a lot of people, even physicists, say that, well, gravity works for predicting things. But then at the same time, they'll say that, there's got to be another body out here because the
Mhm.
planets aren't moving how they should
They're
according to gravity. Didn't you
they're
just tell me that gravity works and you measured it all and it's
yeah,
okay and now it's
their
not?
biggest claim would be the story about Neptune that they tell about how they predicted where Neptune was at based off of the what was it they say that like Uranus was out of position or it was like off tilted or something they say about Uranus, and they're like, well, based off of how it's off centered, there must be a gravity thing here. But what they don't tell you is that there was like hundreds of different predictions by hundreds of different people, and they all gave different values and different magnitudes for the displacement. And the whole story that they ended up settling on, when you go through, because it's supposed to be like historically archived through the Royal Society's papers that go back between, I forget the names now at the top of my head, but what it comes down to is Airy, of our boy Airy's failure, requested all of the communications regarding the calculations for Neptune, like the whole archive for it. And then this archive went missing for, I forget the amount of years, so I don't want to even say now, but that went missing for years. And then they mysteriously found it with some missing stuff, and when you backlog everything to see if their corrections were accurate, apparently they don't even correspond to like where the position of where Neptune would have been to cause that initial perturbation of Uranus to have them like suspicious or whatever. It wouldn't even have been in that vicinity at that time, because now that they know it, they can like rewind where it was at. Wouldn't even have, like, none of this stuff is even. It's all a fairy tale. But they tell it in such a nice way that the end result is, yeah, dude, we looked up in the sky, saw this one thing behaving irregularly, and we determined that was due to the distribution of mass of this thing over here. And it's like they have this well-formed story. Like, they don't tell you about like, oh yeah, everything backing this up are in the archive sense was missing for, I don't know the years, but and then it reappeared with stuff missing from it. Yeah, okay, dude.
It's like telling a story, but your hero can never die, right? But it's like a parent telling a kid who wants to go to bed. It's like, all right, and then the Johnny Hero eaten by the dragon and he died. Okay, good night. And then, so the lava sprouted up and he had an invisibility cloak, which actually made him so he didn't die from the lava that just killed him. Like, he just keeps onward and onward and going. And that's how they've saved their model, as each debilitating step and mathematical inaccuracy comes up. Every experimental validation, they fail, and they're like, oh, well, you know what it is? Dark matter. 95% of it matter is dark. We just can't see it. Oh, you know why we didn't measure it? Yeah. Well, the measuring instrument contracted in the exact amount of space-time contracted around it, so that the measurement is right, but we'll never see it. What do you think?
Yeah, I mean, they lock themselves in so hard to the observation and the periodicity relationship that when it doesn't match with other things, they're just like, oh, well, you know what backs it up though? There's actually missing mass there that doesn't interact with light. What? What does that
Even
mean? Well, we can't even actually define it other than like, a mathematical variable and a cool
yeah,
story.
based on the fact that I'm right.
Based on how right we previously calculated how right we were, we actually
Yeah,
can't be wrong.
So therefore, it's 95% dark matter. It's not that we're 95% wrong. It's that the things that we're measuring are 95% unmeasurable. Dude, like, if we were to come out with stuff like that, it would be laughed out of the world, right? And this is mainstream science where they're like, okay, we were wrong by, we were off on a scale of 10 to the 36 trillion. But no big deal. And NBD or whatever. People are like, oh, that's cool.
NBD. Yep. Oh, and a real quick note on the Cavendish measurements, right? Because they've been repeated, people do them, et cetera. They do them under different circumstances. They get the similar measurement, et cetera, right? Now, before Cavendish, there was Coulomb who did his thing and measured a similar angle relationship, right? But they're saying that in this, where they've dispelled all the charge, there's no charge, they've isolated gravity, even though we're in a dynamic gravitational system, and in the position of the heavenly bodies, particularly the moon and Jupiter and the sun, would influence these ball torsion measurements, and you would have to calculate where they're at and like do like a differential when they're in different positions to zero out how much they would have influenced it. But forget about all that. We've got this ball and this wire and this angle, and we're building off of that entirely.
It's crazy, man. And all that really, as Taylor pointed out, is based on the Copernican principle, dude.
And so, in building off of that entirely, right, they have an established lore now where they've differentiated between this previous measurement that seems to happen for some electrostatic magnetic relationship or whatever, right? And then they do the same thing where they've dispelled the charge, but it's still occurring, but just to a smaller degree. And they're like, oh, this smaller angle, this one's the gravity angle. The big one, that's not gravity. This one's they could be literally the same thing, but they're just measuring it. It's just a smaller thing, right? So that's all it is. Now, the causal mechanism more is what's in contention rather than the repeatability of the measurement, right? Because like if this is like a repeatable thing and it can be done. Now I've heard the accuracy stuff where they can't repeat it, yada yada, but I've seen more well-tailored professional experiments done, like the recent one that was done with gold flakes or whatever. And keep in mind, these are like the weights on these things are ridiculous, right? But like just given a maximum benefit of the doubt, like you don't even have to just like, let's just give it to them, right? Let's say that this is a phenomenon that occurs and we have this relationship. Now, what do we do with it? Okay, let's test Earth's velocity using light. Nope, no velocity there. Let's test it using the rotation of galaxies. Nope, can't do, or using the using the mass of galaxies based off of their luminosity and their rotation rate. Let's see how we can incorporate gravity there. Oh, nope, doesn't fit there either. Oh, well, how about on the subatomic and the quantum? Nope, doesn't fit there either. No, guys, we're looking for the gravitational, we're looking for the graviton. We can't find it. We've incorporated an entire model that is a specific set of three forces that aren't gravity or electrostatics. No, not those. We've got this, but we're also looking for another force that'll somehow work with our other three fundamental forces that leave no room for any other calculations. But we'll definitely find it, guys. They're not going to find it. They'll never look. They're not even look. They can't find it. It would ruin all of their calculations. All of their coefficients would be destroyed. The we're looking for the graviton is an illusion. If they found it, it would disprove everything that they've calculated so far. There's no room for it. They've explicitly tailored the absence of what they're trying to fill with the three different mediations that they've added: the strong nuclear, the weak one, and the other one I forget. But they got nothing. It's all illusory.
Built upon models, built upon the sun angles, built upon observations of the sky, mathematically reified. Dude, it's exactly how they built it, just upon each other, and then up and up and up you go, and then you get 3 generations of people who got taught something wrong, and everyone's dumb now.
The Tower of Babel is mainstream physics. They have a universal language of mathematics, and they've built an empire to this that extends to the sky that doesn't mean anything. But it's like,
Well, dude, I'm gonna butcher this quote, but Michael Brenner also said that like the language of scientists now has been used to elevated mathematics because the concepts with which they're describing are so retarded that if the common person were to hear them in like everyday speech, they start questioning and go, "What the hell, you guys? You're measuring a velocity of light against a ratio of a thing that doesn't exist for what?" Can you guys tell me? So, like the fact that they've restricted science to elevated language is so they can get one over on the masses and appear quote scientific, and really they're talking about mathematical nonsense and reified nonsense and garbage. And if you put it in layman's terms, they would get called out, and that's why they specifically don't ever do that.
yeah.
Mm.
And if you don't agree, you don't even get to play. It's why you can't deviate. You
Well,
have to be
if you
within
don't
the structure.
agree, you don't understand it. That's the conclusion. Obviously, if you don't agree, you don't get it.
Essentially.
Yeah, and even if you agree with like 90% of it, but there were some people in India that were trying to get papers published on, disproving what they're saying about the Big Bang and, had a different idea, and they couldn't even get it peer reviewed to be published. Like they were blackballed, and people would just send all their papers back without reading them.
Yeah.
So yeah, if you don't play the game, you don't get published and you don't get your doctorate, and that's it.
Yeah. The book Seeing Red by Holden Arp was a really good read. It's not too technical, but he goes into a lot of scenarios and examples of his career where he got, thwarted by mainstream academia, where the referees that are in charge of the peer review process just simply wouldn't. They were like, "What? You don't get? You think you? Hold on a second, guy. You have your own idea? No, 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 no."
You
And it
think
would
you're
just
smarter than
happen
Einstein,
over
bub?
and over and over, and they would, just deny him to the point where they ended up banning him from being able to use telescopes in America. He had to go overseas to use telescopes. They didn't want him because of his credentials, right? Like the things that he was saying about the sky would have weight because we could say whatever we want about the interpretations, no one cares. But if a guy that went through their pipeline starts saying something similar, ooh, that's bad news. It's bad news.
Is that why everyone reacted so negatively to our friend Dr. Mike with his with his statement and his project? They were like, "Oh, it can't be. He must have done it wrong. That's not right." Well, he must not have done it right. No, he must not have measured it for real then.
Yeah, that's why they can't address the actual argument of what the celestial theodolite is, and they're like, "But the star is over here, so we know it like refract." Like nobody cares. It got occulted here by this object that's physically at this angle. GG.
Stop trying to worm you out of it and just send me
Yeah,
feet, please.
yeah. But if we refract, and then nope, no, nope, don't care.
Dan, what else we got?
Well, see,
Big G Day.
we were talking about the ridiculousness of math becoming reality. There is an upcoming presentation on Ether Cosmology on Tuesday that'll be about coordinate systems and reference frames, going over classic physics and the implications of what they're doing with the math and what it means to derive a reference frame and where they're applying it and what they're conceptualizing it and how it falls into modern cosmology and where they've deviated with relativistic physics and the absurdity of what's been done. So instead of using an absolute frame to get out of that predicament, where because that implies like if it's absolute, who put it there, like, right, that's crazy. So they're like, in order for that not to exist even conceptually, mathematically, or philosophically, they're like, you know what, actually, when you're moving, time and space are separated and they're not actually connected. And nothing really means anything, and all motion is relative because there's nothing that connects anything.
Man, philosophically
Eh,
though, that it makes more sense when you factor in, well, from the Copernican principle standpoint, like we have to under the pretense that we're not special, we're not at the center, we're not created, everything came from nothing, abiogenesis is real. You have to go through these 5 tenets, and then you can try to approach this, and you're like, well, obviously we weren't created and we're not at the center, and there's no absolute space, so we'll have to reflect a little, you know what it is, little pockets of time dilation are spinning all around the world, and when we don't measure it right, it's because we got caught in one of those. That's how you get to an answer like that, because your starting framework is so stunted that you can't even, you can't properly analyze it, dude.
Super bankrupt. All right. Well, if there's no thoughts or questions on anything that was presented, we can go ahead and wrap up for the week. See you guys on next week. So, Zach, what do you got coming up this week?
We will be back for Iron Realm Media tomorrow morning. We weren't there Friday. Josh had eye surgery Thursday, and went really well. He can see again through that one eye at least, and he'll have his next surgery for the other eye this Thursday. So I doubt we'll be here this Friday, but Monday and Wednesday we'll be there, and then we should be here for Globebusters Tech Thursday night at 7 p.m. Eastern.
Awesome, man. Awesome. Shane, what do you got coming up, good sir? Got any debates lined up? I heard. Aren't you supposed to be
Do we?
debating someone? Wasn't there a Glover champion that was going to debate you on maps?
Yeah,
Did
so
that happen?
Jaren kind of took this wind out of my sails on that one because he was my debate platform, and now nobody
Ah,
can talk about Jaren without attacking him. So I don't think he's doing debates right now. Although I would
ah.
still like for him to moderate a debate between me and Mordawan, dude. Yeah, the dude who paid me 10 grand for an eclipse prediction also wants to debate on maps. However, I don't think he's betting on maps, so maybe maybe lessons
Indeed.
were learned.
Indeed. Shout out to Morty.
Yeah, we should get that going though. But yeah, what we have going this week is your awesome presentation. That's what we're doing, and then we got our TikTok Wednesday, Thursday home and away games, and got Flat Earth Friday maybe.
Hopefully. Inshallah. Inshallah.
What does that
All
mean?
right. God willing.
Oh,
All right. I'm going to close this out.
Thanks all. Love you guys.
cool.
Have a
Thanks.
great